friends, we have a triangle question here. Given to you is a triangle and A and B are two sides and A is an angle. What is C1 and C2 are two values of the third side C. Okay, so what is this? This is an ambiguous case we call. Let me draw and show it to you. Okay, if you already know, then fine. Okay, let's draw a base. Okay, you already know the angle A, so let's draw an angle A. Let's say right here. So I'm going to call this vertex A because this angle is A, and then I will chop it off here at a length B, okay, because B is given to you. Okay, now A is also given. Okay, now let's say A is this much length. Okay, I draw A here, this much length. Okay, but do you think I could have even drawn A like that? Okay, the two lengths are same, right? You could have either drawn A like that or like this. Okay, there is where the ambiguity pitches. Okay, now what I'm going, I have two vertices now, right? One is B1 I'm going to call and the other is B2 I'm going to call. Okay, let's call this C, of course. Okay, so what happened? That you got length of C to be two values. Okay, one it could be C1, okay, and C2 would be this complete thing. So do you see what two triangles they're talking about? Okay, triangle AB1C and the triangle AB2C. Now what are they asking you? See, sum of the areas of the two triangles is which one of these? Okay, so basically you have to sum the areas. What do you know about area? What's the formula for finding area for triangle? Simple, half times base times height. Okay, so what is the height? Can you get to know what's the height here? Let's call it CD. Okay, CD is the height. What is CD? You know B, you know this angle is A. So do you think CD would be B sine A? Okay, you can use the sine function. Okay, so let's write half into base. Base is C1 for this triangle, right? C1 and then B sine A. For the second one, similarly, half C2 again B sine A. So very simple, right? You just get half B sine A, you just take out and you're left with C1. That's your sum of the areas. But what? None of the option has C1 or C2, right? So you have to get that value. What is C1 plus C2? Okay, work with the side. Okay, so what do I do? Okay, let's say, okay, let me draw here. Suppose you know this side and this angle. Okay, so two sides and an angle here. Can you write the length of the third side? Hmm? That is cosine rule, right? Okay, if this is, okay, so let me write the cosine rule, which I'm going to say. Let me just quickly write cosine rule if I have seen. Let me write a square. Okay, this third side is a. Okay, a square is equal to b square plus c square minus 2bc cos of a. How is that going to help me with two values of c? Quadratic in c. You see that? Let me rewrite that. So you're getting c square minus 2b cos of a c plus b square minus a square is equal to 0. That's the quadratic in C. What do you need? The sum of the two roots you have here. So use your concept from quadratic. Okay, C1 sum of the two roots. That would be normally you know minus b by a, right? So in this case it would be 2b cos a. Okay, now let's write it here. I think we are done. Okay, so this and then you're going to write this is 2b cos of a. Is that any of an option? Yeah, I can see the first one. Okay, because you can write this is b square and then you can write sine 2a. That's the option. Any other option? The second one also looks feasible because they are writing the value of cos of a. So let's start writing. Okay, so I write b square sine a. Okay, 2 I'm cancelling. And for cos of a, can I use the same rule again? Cos of a, what is that? Cos of a, b square plus c square minus a square upon 2bc. Okay, now 1b gets cancelled and you are left with b over 2c, b square plus c square minus a square sine a. Is that an option? Yes. Okay, so these two are correct and you clearly see that these two aren't. Okay, so again, nice question. See you with another one soon.